We're going to hear now from Kathy Bodine, who is the Associate Professor in the Department of Rehabilitation and Physical Medicine at CU's School of Medicine and the Principal Investigator of CU's Rehabilitation Engineering Research Center for the Advancement of Cognitive Technologies. Kathy will give us a brief, very brief, overview of some highlights of the RERC ACT-2 in its first year. RERC ACT 1 and 2 have been the largest recipients of Coleman Institute funding at over $1.6 million. Here's Kathy.
Thanks. Thank you, dear. Okay, I have to start this by acknowledging Bill Kale, who skipped his book club this afternoon just to hear us talk today, so thank you, Bill. It's really an honor to be here and to talk about where we are in our RERC for Advancing Cognitive Technologies. As many of you know, we were first funded by the National Institute on Disability and Rehabilitation Research 7 years ago as of this month. We are in the second 5-year go-round of our RERC. We have been immensely supported by the Coleman Institute for Cognitive Disabilities. We are so grateful. This is roughly about a $10 million project over 10 years, and so it's very exciting for us to be able to put these resources into advancing cognitive technology, so thank you. Before I get started, also I want to recognize our partners. Those of you that are still in the room that are with our RERC, could you please stand? Yay. And if you'll stay standing for a second, would the Assistive Technology Partners team please stand? All of you who's here? Okay, this is a small number of our group. And my point is, this is not about me, this is about our team, and this is about the work we're doing at the University of Colorado and many places throughout North America. My co-chairs and my co-PIs are Michael Leitner, who is not here today. I'm going to get him for that. And also Dr. Clayton Lewis, who serves ably as a co-PI with me. Okay, so what are we doing with this RERC? Well, there are 23 million Americans with cognitive disabilities. We're all aware of that. Worldwide, there are somewhere between 235 and 549 million people with cognitive impairments. That is a large market. We'll have the World Health Organization should be out momentarily. The new data, the 10-year data is coming. And when you see that, I think you'll also see some numbers that are surprising. So what are the themes of our RERC? Well, first and foremost, one of the things that has not happened in any assistive technology for people with disabilities is there has not been usability testing or product testing. In other words, there are no FDA approvals required. It's just whatever's out there is out there. So we don't know how well it works or how good it is. So we've launched a product testing lab, which is led by Greg McGrew, our rehab engineer. We also are very interested in the development of guidelines and standards. Clayton is working on this. Peter Axelson, a number of folks on our team are really looking at the development and coordination of all the different standards groups around the United States and abroad who are working on standards. And this is moving very nicely, and we're very pleased with where we are with that to date. And then the other thing that we looked at, and I'm going to talk and highlight mostly this area, is a project that is made up of multiple projects. And it's that notion of, if you think about Microsoft Office, theoretically, once you buy Microsoft Office and you learn Word, then you can learn Excel, and then you can learn PowerPoint, etc. For people with cognitive disabilities in particular, there is no lifespan approach to technology. Every time you change and your technology changes, you start over. If you get a new caregiver, you start over. And we want to change that. We want to make it transparent and simple and easy for people to move throughout their life using the technology that works best for them. So I'm going to talk about that project. Now, I'm going to be academic for 2 seconds, because if you're an academic, you have to have a conceptual framework or a model. Okay, so there it is. I won't go into it, but suffice it to say we're doing research, we're doing development, and everything we're doing is tied together. We're not doing 12 separate projects. It all works together, and it all centers on the notion of iterative testing, iterative work, iterative research, iterative development, so that we turn out products and services that work when we're done. Okay, so let's just talk about what the problem really is. If you are either born with or you acquire a cognitive disability, turns out that just like people without disabilities, you change and grow over time. Who knew? So the problem with that is that current technology doesn't fully support the activities of people with cognitive disabilities across the lifespan. And so there is a critical need to develop technologies that work. They need to be useful, and they need to provide the correct support when you need it, where you need it, how you need it. And that's really the summary of everything we've been talking about for the last couple of days here, I think. So any solution that we choose or we work or we deploy on has to take advantage of the latest and the greatest in mainstream and assistive technology research and development. We can't mess around with people's lives. So it also has to provide those specific types of support you need. I don't know about you guys, but it's 5 o'clock and I'm tired. What I need right now is not what I needed at 8 o'clock this morning when I walked in here. We all change throughout the day and throughout our lives. So sometimes I like things to be auditory. I like to hear it. Sometimes I like to see it, and sometimes I like to read it. Sometimes I need a combination of that, but I need it when and where I need it. And that's the same for people with cognitive disabilities. The solutions have to be transparent. They have to be scalable. They can't just work as a one-off every other time we have to create something new. They have to be affordable, robust, and please, they have to be learnable by people with cognitive disabilities and, importantly, their caregivers who are going to be their support. So what are we doing? Well, at the University of Colorado and with our multiple partners all over the place, we're developing essentially a platform, as I mentioned, and that's our best analogy that we can use. And the idea is to approach it and look at some really complex problems. So we're using essentially the same technology. We're leveraging a number of things we did in our last RARC. For example, Regan Zane at the University of Colorado Boulder is doing some wonderful work in batteryless power sources. So we can take context-aware sensors and not have to worry about power because we can harvest power wherever it is. So you put the sensor up and you're done. You don't have to come back and caretake it. We're looking at animated agents. Dr. Sarl Van Vuren has led that, that are just amazing. An animated agent is a figure, and I'll show you the pictures there, someone who has a big word, anthropomorphic features. What that means is if you smile, your eyes crinkle. In our case, when she smiles, her eyes crinkle. And she's very engaging to people with cognitive disabilities and draws you in and makes you want to interact with her. So we need to have something that's comfortable. We're leveraging our notion of non-linear prompting. So in other words, when you do something, you don't always do it in the same way, the same time, every time. Things happen, exceptions or errors. So if you're working in a job and it's a static job, which is our first project, and you're standing at a workstation, you're not going to make the same mistake every time, nor do you need to be prompted necessarily every step of the way. So we want you to be able to be prompted only when you need help. And so that's the project we're working on now, pulling all of these technologies together, and there's all kinds of things we don't have time to talk about that go into this as well. So that works really great for the thousands and thousands and thousands of people who work in static jobs, meaning they don't move around. The next phase is looking at mobile jobs, jobs like maybe being a janitor. You move around in your environment. So you have to have these sensors that work for you in multiple environments and multiple situations. We went cloud last month, so this is all web-based in the cloud, and so we will have a mobile platform. We have a mobile platform that will be integrated into this for people that have jobs where you move around. And then to go really crazy, Jim Sandstrom, one of my colleagues, is leading a research area on socially interactive early childhood robotics. This isn't robotics in the classic sense of build a robot and play, but rather when children are born with developmental disabilities or developmental delays, they have a very difficult time achieving developmental milestones, things like moving, reaching, grabbing, babbling, early language development. Those things are really hard, and therapists and families are required to do thousands and thousands and thousands of repetitions to help this child acquire those skill sets. Well, why not do it with context-aware, censored robotics, toys that know how to engage you and that can elicit these responses from you so that there's more support in the environment and more repetition so that hopefully you can acquire those developmental milestones at an early age. Again, we're using all of the same technology platform. So we're into the early stages of researching that. We're very excited about how it's going to go. So where we are now, how are we doing it, excuse me, is that we are starting with use case analysis. At my shop down at the med school, we don't do anything unless we involve the very people that we're trying to serve. So we are bringing folks in and we are doing use case analysis. We're trying to understand with the potential end user exactly what their needs are and how they can best be met. And that's, I think, a wonderful thing. The other thing we do that's a bit unique is that we have engineers and clinicians in the same room at the same time with our potential end users so we can all learn together. And it makes an incredible difference in the end product. We are engaging technical and our clinical experts at CU and throughout North America for our development. We have iterative design testing getting ready and underway, and a number of other research projects that really do include those people who might use them. So that's a very brief overview of a very complex activity with lots and lots of players in it. I want to talk a little bit about leveraging activities because that's something Dr. Braddock always likes to hear about. So one of the things we were able to leverage this year through our clinical Translational Sciences Institute at the med school was a $500,000 NIH grant to do a comparative device trial of augmentative alternative communication devices. So for children 6 to 12 who are non-speaking, who use communication devices, we're actually doing a multi-site clinical trial, California, New York, and Colorado, to determine what's the evidence, what's the impact of these devices for children with Down syndrome or Fragile X syndrome who are unable to talk. We cannot find in the literature where this has been done anywhere else, so we're very excited about this study. We also launched our product testing lab and have been working with any number of companies. We're getting lots and lots of contacts on that lab because it turns out other people want to have their products tested and they want to make sure they're doing the right thing. We have sabbaticals coming up. Dr. Alex Miheliadis, the University of Toronto, who is doing our video sensing part of our nonlinear context-aware project, will be with us January 10th at the University of Colorado. In our shop, he'll be working with our lead engineer, Mike Malonis, and the rest of our team to put all these parts together and to try to get this project way in advance of schedule. We also have Dr. Joel Bach, who's also been at the Department of Orthopedics at the med school for a number of years, who's now at the School of Mines. He's both locations leading the biomedical engineering work at School of Mines. He will be with us for 12 months doing a sabbatical, also learning about technology and bringing the School of Mines students into this picture. So we're very pleased to have that leveraging opportunity. We also are blessed. We currently have 6 students in our lab at Anschutz right now. 3 of them, Tyler, Jared, and Melinda, are working on our RERC projects, and they are just absolutely fantastic, and we're pleased to have them in our shop. The other thing we're doing is working on international conferences. Beginning in 2011, there will be cognitive technologies tracks at the Assistive Technology Industry Association, both in Chicago and Orlando in 2012. We will be internationally in Canada at the Festival of Conferences on Disability and Technology. This will be in June of this summer. This is where in Canada they bring, this is the second year they've done it. It's pretty amazing. They bring 6 conferences together in one place, from aging to early childhood, all around disability issues. We will be running a cognitive track there as well. And then in June, we'll also be heading out to Istanbul. The National Science Foundation is funding 50 of us to meet together from around the world to talk about what we're going to do next in technology and disability, with a particular emphasis in cognition. So we're very pleased with how our leveraging has gone for the last 12 months. And again, we want to thank NIDR. Thank you, Sue, as well as the Coleman Institute and the Colemans. So thank you very much. That's my quick overview of what we did this year.